So we're starting section 4.4, the shape of a graph. And we want to discuss concavity and the second derivative test. So let's talk about concavity and what does it mean about the direction of the graph, increasing or decreasing, and concavity together. So if you break down a circle into four pieces, one piece over here, and the other piece over there, and the other piece over here, over here. You can notice then that the one up here is sitting below the tangent line, so it's concave down, and it's increasing. The piece over here is sitting below tangent line, therefore, and it's concave down, and so it's decreasing and it's concave down. Below the tangent line is the concave down. These two pieces on the bottom are concave up. One of them is decreasing, the other one is increasing. And so these four options are the options that you have that are relative to the direction, increasing, decreasing, or concavity up and down. Now, how do they relate to f prime and f double prime? When a function is concave up, that means that f double prime is positive on that interval. If a function is concave if a function is concave down, the second derivative is negative. F double prime is negative. If function is increasing, f prime of x is positive. If a function is decreasing, f prime of x is negative. So now match all these, increasing and concave up. So concave increasing means you have to put a increasing piece of tangent line. Then concave up means that the function should sit above the tangent line. Increasing and concave down. So again, tangent line should go direction in a positive direction up, and concave down means piece is underneath. And similarly, decreasing tangent line, then you put a piece of the function above it. That go a little below, but I meant to be above. Again, tangent line decreasing and below because it's concave down. And so again, with the information that you have, and usually you start with the tangent line, then you, according to the concavity, you decide which of these pieces you choose. Basically, for example, in this row, I decide according to f prime bigger than 0, the tangent line will look like this. And then I decide by the concavity. For this row, according to the tangent line being negative, in the direction decreasing, I'm going to go put the tangent line in, and then concave down goes below, concave up goes above it. And that's how I choose the shape of the graph. Now, let's do a few examples. Example 1, the function f records the temperature in degrees Celsius. Recorded 3 hours after the sunrise. At 3 hours after sunrise, you're uncomfortably hot. So I'm hoping that it's not going to get hotter, but I may not be that lucky. How do you feel about each of the following scenarios? So f prime of 3 is positive, it's equal to 2. That means that then if I draw the tangent line, it looks like that. Then I will have, and then it says f double prime of 3 is 4. That means it's a positive value. So the piece of the function is going to sit above the tangent line like that, right? And so This is like increasing, the temperature is increasing and fast. Oh, scenario A is bad. Let's go to scenario B. Scenario B says f prime of 3 is negative. Oh, I like that. F prime of 3 is negative. And then f double prime is positive. So basically, the function is sitting above it. And so it's decreasing, but it's gonna kind of and eventually not go sharply. Then I have the option that goes f prime of 3 is 2, and then f double prime of 3 is negative 2. So it's right here. This is a better option than A, worse option than B, because still increasing, but it's not increasing as sharply as A did. That was the worst option. And then the fourth option is decreasing, because this is negative, and then we have this, so it's sharply decreasing. I like this option. That's the one that I want. It's the not only